Now let us go through some problems from the fourth chapter of icse 10 standard. The question is like this: a scale, a half meter scale. So always remember, when it is a half meter scale, it is from 0 to 50. So if you instead of that, if you write the 0 to 100, the whole answer will be wrong. So half meter scale 0 to 50 is balanced at its center, so it is 25 centimeters, and you have a weight of 50-gram force suspended from 10 centimeters from one end. So this is 10 centimeters and you have 50-gram force, and you have at 45 centimeters you have a unknown weight which is W, and the scale is in equilibrium. Means it is neither turning right towards the right, neither turning towards the left. So when you come across such problems, you must be aware of what is principle of moment. Before that, you should know what is moment. For example, assume a body being placed horizontally and you are applying a force over it. Now because of that force, the body will be having a translational motion. It will go straight somewhere like this. Assume the same body is hinged or pivoted. Now you apply a force along its hinge or that pivot. So you are applying a force. Now the body won't move because it is already hinged, or the point is pivoted, the body is pivoted. Now if you apply this force just at distance from the axis of rotation, then that force lead to the body to turn about that axis. So the same force, because it is being exerted at a distance from the axis of rotation, makes the body to turn, and this force is what you mean by the moment of force. So what is moment of force? A force which is being applied at a distance from the axis of rotation. So when you write down, you will write it as force into perpendicular distance. So this I just denote to write the perpendicular distance from the axis of rotation. Now this moment of force, also denoted by the letter tau. As you know, the force is having unit Newton, the distance unit is meter, so moment of force or torque's unit is Newton meter. Now if the force is exerted at this point, the body turns in anti-clockwise direction. If the same force is exerted at this point, the body will turn clockwise direction. So when you apply the force, and depending upon the position of the force from the axis of rotation, the body can either turn clockwise or the body can either turn anti-clockwise. So conventionally, anti-clockwise moment is taken as positive and clockwise moment is taken as negative. That is convention. So why did we discuss this? For a body to be in equilibrium, see, my body is in equilibrium and a number of forces are acting on that body. So if it is in translational equilibrium, means neither it is moving towards right, left, up or down, then we can say all the forces which may lead to its translational motion are cancelling out. Along with that, the forces may make the body to turn about some point, about its center of mass or about a point which it is suspended. So in that case, we will say that anti-clockwise moment, which may turn it in the anti-clockwise direction, is balanced by clockwise moment. That is why the body is in equilibrium, and this is what we mean by the principle of moment. So when an anti-clockwise moment is balanced by the clockwise moment, the body is said to be in equilibrium, rotational equilibrium rather to say. Now in this particular problem, a scale is suspended, 50 centimeter long scale is suspended, and you have 50-gram force being at 10 centimeters from one end, and you have unknown weight on the other end. Still the body is in equilibrium, rotational equilibrium. So you can say anti-clockwise moment is balanced by clockwise moment. Now what is anti-clock moment? Who is making the body to turn anti-clockwise direction? See, this weight 50 gram is acting downwards, so the scale may be forced to turn like this. So that is anti-clockwise direction. So how will you find that? Applied force, that is 50 gram force, multiplied by perpendicular distance from the axis of rotation. See, this is the axis of rotation. From about this point only it can rotate. So distance should be taken this, not the from this end. So normally students will choose already 10 centimeter given, so they will take it as 10. No, it is from the axis of rotation you have to measure. So 25, this is 10, so this distance will be 15 centimeters. So 50 gram force into 15 centimeter makes it to turn anti-clockwise. Now since it is not turning, you have to find the clockwise moment also. What is clockwise moment? So W gram force, so W is acting, that much weight is acting downwards to make it turn clockwise. How far from the axis of rotation? This is 25 and this is 45, so it is 20 centimeters. So W will be equal to 50 multiplied by 15 divided by 20. So this is 3, this is 4. So 150 by 4 gram force is the W which you have suspended. So this is how you are using the principle of moment to find out the unknown weight which is suspended. Now let us move to the next problem. Again you have a half meter scale. You have a half meter scale and you have one knife edge 15 centimeters from one end. So this is 0 and this is 50 centimeter. So one end. Normally if a scale is balanced, without any weight on right end or left end, it should be balanced only at the half mark. So 25 centimeter mark is where it gets balanced. But in this particular case you can see this is balanced at 15 centimeters from one end and you have 35 gram being suspended from one end. The question is find the mass of the scale and find the force on the knife edge and in which direction does the force on the knife edge acts. Whether you are suspending or not, the scale's whole weight will be felt at its midpoint. If this is 50 centimeter scale, you can take a 50 centimeter scale on your finger and you can balance it. Where do you balance it? Normally you would balance it at 25 centimeters. There is what we assume its center of gravity or center of mass is being felt. What is center of gravity? The point about which the whole weight of the scale is being felt. Or you assume that the whole weight of the body is being felt. So that is, so normally for a scale it is a half meter mark, half of it. So in this case, in this question, we should assume the scale's weight is being felt at 25 centimeters because whether you have suspended 35 gram or not, the weight of the scale is always felt at its half mark. So 25 centimeters is where the weight of the scale is felt. Now since they have given it as find the mass of the scale, so let x be the mass of the scale. Now it is in equilibrium, means it is neither turning right neither turning left, so you can assume clockwise moment is balanced by anti-clockwise moment as per the principle of moments. Now who is making it to turn clockwise? See, here is a knife edge, and if this 35 gram is not there, then this weight of the scale or the mass of the scale will make it turn clockwise. So x, the mass of the scale, multiplied by the perpendicular distance from the axis of rotation, that is 15, this is 25, so 10 centimeters is what the clockwise moment is. And on the other side, who is making it to turn anti-clockwise, that is 35 grams, multiplied by the perpendicular distance from the point, that is 15 centimeters. So you can easily find the mass of the scale as 35 multiplied by 15 divided by 10. So this is 1.5, 35 into 1.5. So 35 plus 17.5. 45 plus 17, 52.5 grams. So this is the mass of the scale. Now, so it means here you are feeling if mass of 52.5 grams. Next question is, what is the force on the knife edge? See, what do the knife edge feel? See, knife edge is balancing on one side 35 grams, on the other side it is feeling is 52.5 grams. Means assume knife edge as yourself. So on one side you have some weight, on the other side you have. So what do you feel? You feel the sum of both. So what is the force felt? What is the force on the knife edge? Force on the knife edge is how much weight it is being experienced, that is 35 grams plus 52.5 grams. So you will have 787.5 grams is what is force experienced at the knife edge. In which direction it experiences? Obviously the knife edge is pushing it upwards, but what do it feel? It feels the force downwards. So the downward direction it experiences this force. How much? 57.5 grams. So this is how you have to solve that problem. Another problem, you can see two forces. One is 25 Newton and it is a point Q, and you have another 25 Newton and you have a point P which is 0.05 meters away from the first point, from the point Q, and in between them the distance is, between the two forces the distance is 0.2 meters. The question is, what is the moment of force about Q and P? See, this is a tricky question because you have a force which is acting through Q. So what is the moment of that force about Q? Because you should have a force. To find the moment of force, two things are necessary. There should be one force and also the perpendicular distance should be there. So consider this first force, let this be F1 and this be F2. What is the moment of force about Q because of F1? So moment about Q because of F1. See, force is there, that is 25 Newton is there. What is the perpendicular distance? It is acting along Q, so it won't make any turning effect. So perpendicular distance is 0. So moment of force about, so let me test torque, because of F1 is 0. Now what is the moment of force at Q because of F2? See, F2 is being acting at a distance of 0.2. So you have because of F2 you have 25 Newton being acted at a distance of 0.2. So it will be 50 by 10. So 5 Newton meter is the moment of force about F2. About Q because of F2. So what is the total moment about the point Q? It is 0 plus 5 Newton meter. Now hope you understood, because F1 is acting along Q, so it doesn't make any turning effect. So that if that force was acting at a distance, then it may have exerted a turning force, or you can say there is a value for the moment of force about F1, but in this case 0. There is no perpendicular distance, and F2 is exerting a moment about O because it is at a distance of 0.2 meters. of moment exerted by F2 is equal to F2 into perpendicular distance. So you have 5 Newton meter. What is the total moment about Q? That is 5 Newton meter. And what does it do? It makes it turn the clockwise direction. So what is the direction? In clockwise. So net effect is the Q will be feeling a force to turn clockwise. Now take the case of P. Now P is at a distance of 0.05 meters from this F1. So, and it will make this 25 Newton. F1 will make the point P to turn clockwise. Similarly, F2 will be also exerting a moment about P. So what is this difference? So let it be 0.5, then the problem will be easier. So this is 0.5, sorry, 0.05 and 0.2. So what is the difference? It will be 0.15. So this distance will be 0.15 meter. So what is the total moment about P? This F1 will make it turn 25 Newton. Is acting at a distance of 0.05, that is a perpendicular distance, will make it turn clockwise. Similarly, F2, that is 25 Newton, acting at a distance of 0.15, will also make it turn clockwise. So total effect is the point P will be feeling a force to turn clockwise because of the two forces. So what is the sum? 25 into 0.05 plus 125 divided by 100, so 1.25 Newton meter, plus 25 into 15, so it will be 25 into 15 will be 0.5